Okay, good morning, everyone. Let's get it started. We have a lot of contents to cover today. Uh, there are not so many comments and questions here. I don't know how to interpret this. Maybe things are going well with pandas, which is a good thing. But there's one question. I had problems knowing when to define access to the data frame. If I understand it correctly, you're asking when you should import the data, read the data, and well, generally speaking, it should be when you need it. But if you want to follow the good coding practices, it's usually at the beginning of your script. So you often start by importing your libraries, and then you read the data, and then whenever you need it during your script, you will access it. But yeah, good to see that things are going generally well with pandas. Today we are going to continue with pandas, do a bit more advanced things, doing more a bit deeper analysis of the data. Yeah, so we will continue next week, which well, it's already week 6, so we only have one lesson left. We are almost there, and yeah, next week we will work with visualization. So we will continue working with pandas, but mainly focusing on creating different kinds of visualization charts and so on. So yeah, but before we get started with the actual contents of today, let's have a quick look at the midterm evaluation. I checked this last Friday, and there were 25 responses from you. Yeah, so about the pace of the course, most of you were happy with how things are going, which is nice to hear. Some of you thought it's going sometimes more too slow or too fast, and yeah, good to know. We try to improve this. Well, there's just 1 week left, but in the coming years as well. Lesson content difficulty. Most of you thought that the difficulty level is good. For some of you, the course is a bit, at least the first few weeks were a bit too easy, and that's understandable if you have any background in programming. Well, many things are, we start from the basics. So, and that's the idea of this course. But as you notice, things start to get more serious from week 5 at least. So hopefully it has a bit of challenge for everyone. And about the exercise difficulty, again, most of you were happy with how things are. And some of you had asked for more optional exercises in which you can challenge yourself, and that's a very good comment. We can think about that for coming weeks and in the next versions of the course. Most of you like the course website and the fact that the lecture materials the lessons are being recorded, and that's nice to hear. And the least helpful, well, some of you wanted to have exams or some kind of quiz so that you can track your progress during the course, measure your progress during the course. That's something to think about. But we have the weekly exercises and we try to be on time with the grading, so that's kind of one measure of tracking your progress, but this is also a good comment. We can think about this, not this year, but the coming years. And pair programming is always students are very divided. Some people love working in groups, some people hate it, and we haven't found a good solution yet. Yeah, most of you were happy with the course material, this course book that we introduced this year for the first time. That's nice to hear. Lecture recordings, exercise help sessions could do better, and we will talk about this with assistance. Pair programming, as usual, a bit divided opinions about it, and then Discord, which is doing all right. Yeah, and there were some good suggestions about improvement for coming years, which is great, but generally you seem to be happy, and that's very nice to hear. Yeah, let's get it started with the actual lesson of today. So I will start with the course's website to have an overview of what we are going to learn today. Yeah, so as I promised, we are going to continue with pandas, and we are going to do a bit, not more difficult, but a bit more challenging maybe analysis. So we are going to spend more time. Some of you wanted things to be explained a bit better, so I tried to be a bit more detailed with how I explain things today. Yeah, so we will continue with that. Hopefully by the end of this lesson this week, you will be able to analyze data in Python using pandas. repeat an analysis. So for many of us, for many of you, the main motivation why you want to do things programmatically is to automate processes. And today we are going to see our kind of first example of how you can automate things. Of course, you have previously seen like for loops. That's one simple way of automating things. But today we will actually do some analysis on a data set coming from Helsinki, and then we will repeat it for 5, 6 other cities, just like that. So that's one of the main motivations why we use programming in the first place for doing many things that we do. So we will have a first example of that today, and then after that we have some small section talking about errors. You have seen them already a lot during your work, I'm sure. So we will take a bit closer look into how to interpret and how to interpret the errors when you're running a script, and what the steps you need to take in order to debug your code and like make it work as it should. So that's the overall objectives for today. Yeah, so let's go to Noppe. I have already opened my workspace. If you haven't done already, please do so and pull the latest changes from the repository. Now I'm in the lesson 6 folder. I'm going to start with this advanced data analysis, data processing with pandas. Okay, so we have just updated the dataset for this lesson, and it's coming from this summer. For those of you who have spent the summer in Finland, you know that it was a bit unusually warm. We had many warm days, and this is a screenshot from an article from Yle saying that Finland breaks all-time record number of hot days. So this article is actually from 5th of September. So by that day, already we have had we have had 66 hot days in Finland, and hot day, according to this article, is a day that we have temperature over 25 degrees. Now, of course, this is from Finland, so it doesn't mean necessarily, probably, this is something that we are going to test, but doesn't necessarily mean that, for example, in Helsinki, we have had 66 over 25 degree days, but in country as whole. But this is something that we are going to test. So we are going to get some data from FMI, and then we are going to count the number of days in Helsinki where we had the temperature over 25 degrees to see if we come anywhere close to this record for the whole country. And then we are going to test the same thing for different cities to see how this holds for other cities as well. So yeah, there's a link to this article, and then yeah, so we are going to work with the data set. The data set is similar to it's actually the same data as we worked with last week, with the difference that last week we wanted to start things in a bit simple way. So the data was a bit formatted to a certain style that we worked with. Now we work with the original format of the data. So data that we will work with is just straightly downloaded from FMI. And I will briefly show you how you can get data from FMI. It's quite easy. But things that we are going to learn during the lesson today, like one simple thing we will learn is to rename our columns. So that's one thing. Then we will learn how to iterate data frame rows and apply functions. This was a question that came up even last week. And today we are going to look at that. It's a useful thing when you have a data frame, you want to go through rows and apply functions, do calculations. So this is something that we are going to learn to do today. And then one main thing that is quite simple, but it might be a bit hard to grasp at the beginning, is data aggregation. But we try to spend a bit more time there to make sure that we know what we are doing. But yeah, we learn how to aggregate data. And then repeating the analysis test. So at the very end, when we do all the calculations for Helsinki, we will repeat it for a few other cities. And these are the cities that we are going to work with. So we do the analysis on Helsinki data coming just from the FMI station in Kumpula. And then we will repeat the analysis for Lappeenranta, Oulu, Porvoo, and Rovaniemi and Turku. So we repeat the analysis for this. And as I said, the dataset is from summer. This article is published on 6th of September. So probably 66-day hot day happened sometime in early September, but for our analysis, we just focus on summer. So the data is pulled from 1st of June 2024 to the end of August, so 31st of August 2024. So this is the data. And this is where we got the data. FMI has a very good open data portal, so it has a very nice, easy to use user interface. So I guess they also have an API if you want to programmatically pull the data. But if you don't need it, then this user interface is very easy to use. So if you just go, so I have put a link there. If you go there, you will see this kind of user interface. You can choose what parameters you want to have in your data. So in our case, we just use, but the data is downloaded, so you don't need to do that, but just showing you in case you need some data from this resource later on. So you can choose what weather observations you want to have included. In our lesson, we are just working with air temperatures, so it's enough. You just select that one. And then you choose the time intervals. If you go with original interval, you will have a lot of rows. I don't know at what intervals, but they record the temperatures and different things many times per hour. For our case, it was enough to have hourly measurements. And of course, when they have more calculations than once per hour and you want hourly measurement, it has to be a way of aggregating. So then here it asks you, okay, how do you want us to aggregate the data for you? So I just chose mean. So it gives me the hourly average. So that's what we have in our data set. And of course, you should choose the time period from which you want the data. As I said, it's from 1st of June to end of August 2024. And yeah, you choose the station from where you want the data, and then you click on download observations. It gives you a few options, what format files you can download. There's Excel and a few other things. For this lesson, we are using CSV, which works very nicely with pandas. Yeah, so if you want to check out the data, all the data sets from all these 6 cities are under data directory, Helsinki and the other 5 cities. So you can take a look. We can already open Helsinki data. So this is what our data looks like. So it's CSV. Of course, in Jupyter Lab, when you open it, you will see it like nicely visualized like this. It is format. It has some styling already, but yeah, but the raw file is CSV. So comma separated. Yeah, so if we quickly look at the columns we have in our data, we have the observation station, that's our first column. Then we have the year from which we collected data. In our case, doesn't add any new information for us. It's all from summer of the same year. And then we have month, we should have values 6, 7, 8 because it's from summer. And then we have days. Then we have a column time, the time of the day when the temperature was recorded. And a few other things. We also have speed and the wind speed and the humidity. We are not going to work with this. It's just for the beginning. We see how to get rid of those columns. So yeah, so let's get started with our coding. So there's a bit of like, I guess the column names are quite self-explanatory, but there's also a bit of description here what each column means. But let's start by importing our library as usual. So as I said, we are going to continue working with pandas, and we saw that you can import pandas simply like this. And it's common to give a short name to it, so I'm going to give it a short name, PD. So the next line of code is already written there, so it's a path to the file. So you saw that the file was saved under data directory, and this is the name of the file for Helsinki. One thing I forgot to mention is that when you download the data, the file names are a bit different, a bit longer. So we have renamed the files just to make our life easier for this lesson, but the file otherwise hasn't been changed. So let's define the file path. So this is a relative path. It's a good habit to do things like this, so you don't give absolute paths to the file, especially if you're working on your like local computer. If you put exact address to the file, it works fine for your own computer. But if you share your file with data with you, if you share your script with someone else, then that absolute path to the file is not valid anymore. So if you just put relative path, so I'm not saying where exactly the file is, but relative to where my script is. My script is here. Relative to that, my data is under data folder, and then this is the name of the file. So if I share my script with someone else, as long as they have the same folder structure, the code should fine. So that's why we do it like this. So I ran the cell. Now we are going to load the data. In Helsinki dataset, if you go through the data, you will see we don't have any missing values, so the data quality is quite good. But FMI is FMI in any dataset you get from FMI, they usually define the missing values as a dash sign. We will see in some of the cities that we are going to run the analysis on, we will have some missing values. So although we don't have any missing value, I'm still adding it here when importing the data, just in case. And because we are going to repeat the same process for other cities and they might have missing values. So now the data should be loaded. So you already worked with this last week and during your exercise, and again you will work with this on the exercise. Here in this data set, which is relatively clean, the missing values were marked with a dash. They were represented with a dash. They can be represented in many different ways depending on where you get your data from. And we talked about this last week. Like in GIS world, it was common. It is common still to use like -999 for missing values, or it can be different number of stars or asterisks. So yeah, we already saw how we can handle this. So you provide a list of the values that should be interpreted as missing values. So it can be anything. So in a data set that you will be working on, well, something similar to what you will be working on this exercise this week, you will have different number of asterisks. So you can just put a list of different numbers of asterisks and this will work. In our case, it's just dash, as simple as that. So now we are going to explore our data. It's a good habit. So we already saw that one handy way of taking a quick look at our data is using this head function. So I'm going to just run this and take a quick look at our data. Nothing new here. We already looked at the CSV file. Let's also look what columns we have in our data. Again, we have seen this, but as a reminder how we can do this, data.columns. And here is the list of the columns that we have available in our dataset. So you see that there are a number of, as I said, this dataset you get from FMI is quite clean for the reason that in the user interface you can choose what you want. But in many cases you just get a huge dataset from a source. It has so many columns that you may not need for your work. So we saw this last week that you can use calls parameter to define which columns you want to have included in your data. As I said, in the original data we had also wind speed and humidity, which we won't need for this lesson. So I'm going to import my data again, but this time only keeping this information. So the name of the observation station, year, month, day, time, and air temperature. So I'm going to run this and it also show me the head of the data. So now the data looks a bit neater. We have less columns. We got rid of the columns that we did not need for our analysis. So there is one thing that we can still improve in our data before we continue with our analysis, and that's the naming of our columns. I don't know how you feel about that, but I don't like these names when I'm doing data analysis. Yeah, it's nice if you're just working in Excel or just taking a quick look at your data. It's very descriptive, like air, temperature, mean, and then Celsius. It's descriptive, but when you're doing data analysis, if you have such long names, it's a bit difficult to work with. And what I don't like is that we have a lot of signs and spaces in the names. So depending on what you're doing, you might run into issues with it. So what I'm going to do is to rename our columns, and this is the first time we are renaming columns in a data frame, pandas data frame, and that makes it a bit easier for us. Yeah, so we already saw the name of our columns, but let's take a second look to see what columns we have. And then the way to rename columns is quite simple how we can rename columns in pandas. What you need to do is to construct a Python dictionary. A dictionary is a new object type that we haven't talked about, I guess, much before, but there's a link to the documentation showing what dictionary is. But dictionary is basically, it's like we work with lists. It's in the similar, it's in a similar family of data items, data objects, but it's different. So by definition, you have in a dictionary you have a key, and then you have some pair value. So the pair value is attached to the key. So if you call the key in a list, you just have list of values. So you just access the items using the index. So you just want the third or the fourth item in your list. But in a dictionary, you have a key value. So this is an example of a dictionary. So we have names of people, and for people, we have some values, which is apparently like some phone number. So if I want to access the phone number of a person named Jack, I don't need to access it by the index. I don't need to know where it is, like in a list. I can just say, give me the phone number for Jack, because Jack is the item here, so the key for the person. So you can just see if the name of the dictionary is tel in this case, and I provide instead of index, I can just put the name of the person, which is the key in our dictionary. It just gives the number. So the person Jack is paired with this value. So when I call Jack, it's going to give me the phone number for Jack. So this is what a dictionary is in Python, and it's quite handy depending on what you're doing. And in pandas, we use this data structure for renaming. So I give the old name and then the new name. So the old name is the key for the dictionary, like Jack in that example, and the new name is that phone number. So we do that kind of, that's how you rename it. So I'm going to define a dictionary now with the old and new names. So I'm going to name my dictionary new names. And this is how you can define a dictionary. So the dictionary is defined like in a list we had these square brackets. With dictionary you have everything between these curly braces. So you can just copy the old names from here if you don't want to type, because they're a bit difficult to type. But yeah, so I'm going to just copy the old names. So I will start with the first column, observation station. So this is the old name. Then I put the colon, and then here you give the new name. So whatever you want to name it. I want to name it just a station. That's enough information for me. And then I move on to the second item in my dictionary. So this was one item. Now observation station is paired with a station. The second column, well, I want to rename all the columns. So the second column is, you can go in whatever order you want. The order doesn't matter. So I will go with time. Well, these are short enough, year, month, day, so I won't change them, but time is long and it has a lot of spaces. So this is the second item that I want to rename. So for me, it's enough if it's called time. It's descriptive enough. Another column with an overly long name is this air temperature mean. So I'm going to copy the value of that again. And then I give a new name to it. I'm going to just call it temp. So now I define my dictionary. I have the old names and new names. So let's also quickly see what we just did. So I put the new names here so it's printed out when we run this cell. So let's run this. So now we define the dictionary. So you can see we have the key for the dictionary, which is the old name of the column, and the new name, which is the then the pair value, which is the new name for the column. So now we are going to pass in this dictionary to pandas, and the pandas is going to use this dictionary to rename the columns that we have included here. But before that, let's just, since dictionary is something new, so let's check the type. So I'm checking the type of new names variable in which I've stored my dictionary, and you see it's a dict, so it's a Python dictionary. Okay, now that we have our dictionary ready, we can start renaming, and that's very simple. So I'm going to rename it and store it again in the data variable, so I don't create a new copy of my data frame. And for renaming, you just use data.rename. The data is the name of your data frame, and rename is the method that you will use for renaming. And what you need to pass in is the dictionary for the parameter columns. So I'm just going to pass in my new names as the input. The second line of code is already typed in, so we will print the data columns to see if the renaming was successful or not. So now you can see that the renaming was done. So we have now shorter names for our columns. So you can see that the renaming has worked well. Okay, to make sure that we are comfortable with renaming columns in pandas, let's do a quick practice. Let's take a couple of minutes and do this. Then we will do it together. So now we want to rename our column temp to temperature Celsius. So we will rename it to temp_C. So let's just quickly do this and then we will continue. As you can guess later, we are going to do a bit of conversion between temperatures like we have done in previous weeks to just practice how things work with applying functions. So it's good. That's why it's good to rename our column temperature, because later we will have temperature in Fahrenheit, so it will be a bit more clear. So I'm going to again use the same name for my dictionary. I will call it new names. And then we will provide the old and new name. So the old name was temperature. And the new name for it is temp_C. And then renaming the data equals data.rename. Then what we need to provide as the value for the parameter columns is the list we just created, which is new_names. And then we have the data.head already there to take a quick look at our data. So we see that renaming was done. So we have a column named temperature_C. So this is our temperature recorded in Celsius. And later we will do conversion and also have it in other units. So before we continue with our analysis, let's explore some of the properties of our data. These are things we already saw last week. So if we want to get a quick look at how many rows and columns we have in our data, we can use the shape property, shape attribute of my data frame. So you can see we have more than 2,000 rows of data. It's from 92 days of summer, but of course for every day there's 24 recordings. So that's why we have so many rows of data. And then we have 6 columns. Let's again look at the head of our data to make sure everything is named properly so that we can continue with our analysis. I would like to also look at the end of my data frame to see how far the data goes. It should be until end of August, but anyway, it's good to check. Yeah, so you see the last 5 rows in your data are from last day of August, so it seems all right. I'm also curious to see what kind of data types I'm holding in each of my columns, so I'm going to use data D types. These are things we worked with last week. So these are the data types I have. Yeah, so the year is integer. Then we have month, day, integer, time is an object. So for some reason it has read the strings as an object, but doesn't affect our analysis, and we are going to fix this anyway later. And then we have the temperature as float. We have decimals there. Let's quickly get the descriptive statistics for our data to get an overall understanding of how the data distribution is. So I'm using data.describe. And you can see the average temperature for summer in Helsinki. Well, for year and months it doesn't make sense, but if you look at the temperature column, you can see that, okay, the average is 18.4, and then we have the standard deviation 3.4, and other information that might be useful. The maximum temperature we have from summer in Helsinki is 27.3, and the minimum was 8 degrees. Okay, so now we want to convert temperatures. Not that we need it, we are comfortable working with Celsius, but to showcase how you can apply a function to your data frame, we are going to convert our temperature from Celsius to Fahrenheit. This is a function we have worked with a few times already during this course, so we are comfortable with that. We don't have to write the function again. It's already typed in. We have done it many times before, so there's no point in repeating. So we know how we can convert temperature from Celsius to Fahrenheit, and the calculation is there. The function is defined here. We just have to run the cell. Okay, so now the function should be defined. To make sure our function is working fine, I'm going to just test it for a value that I already know in Fahrenheit. So I will go with Celsius. So the name was Celsius underscore 2 underscore far. Oh, thanks. Yep. So that's the name of our function. And then for 0, we remember the Fahrenheit is 32. So if our function works well, it should give me 32. Yeah. So our function is working properly, which is good. Let's again take a look at our data head before we continue. But this is small data, so it feels a bit unnecessary to check it all the time. But when we are working with more complex, larger data sets, it's just good to be sure before applying anything. So now we are going to iterate our rows and apply a function there and calculate. So we will create a new column, data temperatures in Fahrenheit. So as you can imagine, we have previously, when we have used functions, we have had just one input. You provide the input to the function, you get the output like what we just did, converting 0 degrees Celsius to Fahrenheit. But now we have a data frame, so we have 2,208 rows of data, and we are going to apply. We have to, like, of course, manually you cannot do that. It's just so many rows, and that's pointless. So of course we want to automatically apply the calculation to all the rows in our data. So we can use a function one row at a time using a for loop and iter rows. So iter rows is a method coming with pandas data frames that allows us to iterate through the rows on our data, and you can do different kinds of processes. In our case, we are applying a function. So when you're using iter rows, and we are going to see this in practice in a minute, when you're using iter rows, it's important to understand that iter rows accesses not only the values of the row, but also it returns the index value for the row. And now we will see how that works. So I'm going to write a for loop. It's actually typed in, so it saves us a bit of time, which we can use for explaining. So when you use data.iter, so it's an attribute of your data frame. It's a method for your data frame. It's going to return you two things, which I'm handling here. So it gives me two items. The first item, so I'm just naming it here IDX, short for index. You can name it whatever you want. And it's giving me the row. So when I'm doing this iterate iter rows, it's returning me two things: row, the row in my data, and also the index for that row. So this is how my for loop is working. And then I'm printing here the index value for the row and the value of the temperature. So from the row, which you have accessed here, you can of course name the column. So I want to get the temperature in Celsius for that column. So this row, I'm accessing this column. And then I'm putting new line here. So I put a break here. So it's a for loop and you have 2,200 rows of data. So if you don't put this break, it's just gonna print it. You will have 2,200 rows of print. So it gets messy here. So I'm just putting breaks, so it will just run once. It doesn't go to the second loop. That's why we have the break here. So it just worked for the first row, which is index 0. It's our first row in a data frame. And then the temperature is 19.3 degrees Celsius. So this is your way of going through rows of your data. So if I didn't put this break here, I would have gone through the whole data frame and I could do whatever calculation I want or read whatever I want from my data frame. So now we are going to use this to do the conversion between Celsius to Fahrenheit. So the code is typed in here, so I will just explain it. So I want to create a new column in my data. This is how we do it. We have learned this already last week. So we create a new column called temperature temp underscore F. And for now, I just put the value 0.0. So just some random float value. I'm going to repopulate the column with the actual calculations. Then this is again the example of the iteration we just did, but last time we just printed something without doing anything, but now we are going to actually do something. So I'm going to loop over our data rows using iter rows, again accessing the index value and the row of the data frame, and then I'm going to calculate temperature Fahrenheit using my function. So what I'm providing as input is the column. So imagine what you're getting in row is one row of the data at a time. And from that row, you're accessing the column temperature underscore C. And then you're using your function, the one that you defined up somewhere here, to do the calculation. So it returns a value to you that you're storing in temperature underscore Fahrenheit. And then I'm using this temp underscore Fahrenheit to I'm populating the column. So I'm assigning it to temperature F. So I'm accessing my data at index value. This is the index value we read. Assigning the temperature, and this is the value we calculate. Does this make sense or is it confusing? That append? You're not appending anything here. Yeah, append just adds one row to your data. I'm not adding anything. I'm just looking at that particular value and rewriting it. So yeah. Yeah, so I'm not changing my data frame. I'm not adding anything. I'm not removing anything. I'm just recalculating because here I have 0. I'm just assigning a new value. So if we just run this, it should be very quick. So it takes a fraction of a second and we have 2,200 rows of data. It's very efficient. Yeah, so the calculation is done. We are going to soon check how it looks. So we could have achieved the same thing using also data log, and we talked about this, that you can use data at or data log. So it's similar. So now I'm going to use head again to see if the conversion was done successfully, and now we can see that yes, it has been done. So we have the new column added, which is named temp underscore F, and we have the temperatures in Fahrenheit, and they seem right. So this was one way of calculating something. So it was the simple way, and it gives you an understanding of how things work. So you're iterating through your data frame, row by row, doing a certain kind of calculation. In this case, this was the temperature conversion. But pandas has an even easier and even more efficient way of doing this. So for 2000 rows of data, it doesn't make so much difference. But if you have a data with, I don't know, a million rows, this will make a difference. It's more efficient, and that's applying. So using apply method, you can apply a function to your data. And this is how you do this. So I'm going to name the column in which I want to store my new values. So it was temp underscore f. So I'm redoing the same thing, just using a different approach. So now this will be the input for your function. So the input of my function, which column is the input of my function? It's temp underscore c. So I'm going to access that function, that column. So from my data frame, I'm using temp underscore c, and on this column now I'm applying a method. So this is what you use in pandas to apply a function. And here you just put the name of your function, which was Celsius underscore 2 underscore far. Okay, so let's review. So instead of doing the iter rows and looping through the thing, you can just quickly do this. It just does the iteration automatically, and it's more efficient. So here it's the name of the column in which I want to store the new calculations, and this is the input, and on the input I'm applying a function, and the function can be anything. In our case, it's the function we just defined. So remember, since we are providing the input here, in the function, no, we don't need the bracket anymore, because we always when we are using function, we put the bracket and the input. When you're using the apply method, the input is here. So you don't need to put a bracket and provide an input. So we don't do that. It's enough we just write it like this. So if you run this, again, it's super fast. It did the calculation. Yeah. Yep, so now we already stored this in the column. But one thing, well, of course, now we know that this is working well and we already stored it in the column. But before doing that, if you want to check if it is working well and to just view the data before storing it in your column, you can just put this part. So it's going to print out the values for you. So I'm going to do this first. Maybe the order was a bit wrong. So first we check what we get as the output. So you can see that now this is not stored anyway. It's just applying the function on the values and we are getting the output. And like it looks good, so I'm going to go ahead and apply it to our data frame, which we already did. So we don't need to run it again. But yeah, so if you don't provide this, it's just gonna print out the new calculations for you without storing them in your data frame. So one good trick that doesn't apply to us in this case, because we only have one temperature column, but it's good to know, is that you can at the same time do the calculation for multiple columns using this apply method. So if in our data we only have one temperature in Celsius column, but imagine if in our data we had temperature, minimum, maximum, several columns of different units, and we want to do the conversion to all of them at the same time, then as the input, you can just provide all the names of the column. So, and then apply the Celsius. So similar to what we did here, except that you can at the same time put more columns. Now let's take a look at our data. And it looks fine. So we have our temperature in Celsius intact. We didn't change anything there. We have the new column temperature underscore F, in which we have done the calculation and have stored the temperatures in degrees Fahrenheit. So as we saw, if you want to access the rows in your data, if you want to apply some calculation, some function, you have at least two ways of doing that. So one is iter rows, that goes through rows. You have more control because you're going row by row. You can do different things. But with apply, you can just do it with one line of code. It's faster, but it requires you to already have a function defined. Because with iter rows, you can just do the calculation on the fly, on the go. But with apply, you have a function already defined, but it's just more efficient. So if you have a large data set, it's better to go with apply, but both of them work fine. So the next thing, so was this all clear? Good. So now let's continue with our analysis. So we need to, well, one of the things we are going to achieve, one of the main goals of this analysis today is to, we have this many calculations per day. Well, we have actually 24 calculations per day because we have hourly measurements. So we want to, at the end of the day, we want to aggregate our data. So what we are interested in is the temperatures for the day, not every hour. So we want to aggregate the data. So we have to do this aggregation based on something. So I give you a geographical example. Imagine you have populations of all the countries in the world, not by the countries, but by the states or regions in the country. But someone asks you, okay, I am not interested in population of regions in Finland. I want the population of the whole Finland. So how do you do that? So you have information that, okay, Uusimaa is located in Finland. Then you aggregate all the regions which are inside Finland into one new line of data, which is Finland. So you do this the same thing for the whole world. So this is the idea of aggregation. You have very detailed information. In our case, we have hourly measurements. We want to aggregate it over the day. So what we need to know is to, well, we are grouping based on a common attribute, and that common attribute is the day. So we need to know that all these measurements are from the same day, then we put them together. So that's our goal. We need a key for our aggregation. And the key in our case is the time. We want to parse the data, the dates, in a way that we know that, okay, these readings are from the same day, then I put them together. These other readings are from another day. So that's what we are trying to achieve now, but it will make more sense when we start doing it actually. So let's look at the columns where I have the date information. So I will first look at month. I will look at the first 10 rows of my data, particularly at the months column. So this is what you have. So the first column is index, so never mind that. But this is the column where I have the month. So the first 10 rows are from June, so we have 6 as the value. So let's also try, I want to look at the tail of my days to just have some understanding what kind of values I have in my day. So I will look at the tail, like the last 10 rows. And this is what I have. So 31, which is the last 10 rows of our data, is from last 10 readings from August. So it's from the last day of August. So now I'm going to check the data types. You already can see the data type here when you do the head. So I know that these are integer values. But anyway, I'm going to check it again using the method we learned last week. So I use the D type. So the name of the column is month with M capital. And then I'm going to use D types. So yeah, again, what I had seen earlier when I used head, I can see that the column month is integer. So now I'm going to create a column in which I can know which day each reading belongs to. So I have 24 readings per day. In order to create those unique days, I need to know which month it is from and which day it is from. Then I can use that to aggregate it per day. So in order to do that, I will need to manipulate the values, and it's easier for me to do that when I have strings, because we already saw how we can append strings to each other and play with it. So I will create new columns of the month and day. I will just copy the same value except that I convert it to the string. So I want to work with a string. So there are many ways of approaching this. This is just one way of doing it in our example. So I will create a new column called month, but this time it will be string. So I will name it like this, all in capital _str. So I will just some name that reminds me that, okay, this is in a string. And for the value, I'm just going to use the value of the column I already have, which was month. And this is, I guess we saw this already last week, but you can just convert change the type of the data on a column using as type. So I'm going to, you saw that it was an integer, so I'm going to convert it to string. So I'm going to do a similar thing for my column with the day information. So I will call it day _str. And I'm going to use the values from my day column and use the as type method to convert it to str, which is a string. So if we run this, it should create us new column. Two new columns with these new names. So it will be the same value as what we had in month and day, except that it's string now. So if you don't trust me, you can just write data.head and see if it has worked well. But before I do the data.head, I want to still do something. So I want to put this together. So to make it unique for me, I want to put the values in this format. So mmdd. So month dash d. So then it will be unique. I know it's because I don't put year because we only have data from summer 2024. So it doesn't help me in any way. If you have data from 3 years, then of course to make unique days you have to also have a year. But now since I know that my data is only from one summer, I don't need to do that. So what I'm doing here, I'm just creating these values, month, day, date, so that I can use it to create those unique days. So this is what I'm trying to achieve. And we have worked with the strings before, so it should be easy for us to do that. So I'm going to create a new column for storing these values, and I'm going to call it month _day, all in capital. Then I'm going to use the values from the column I just created, which was month _str. So I want to do one trick there. So I want it to be looking nice. Well, in this case, it doesn't matter so much, but you can imagine that if the days or the months are less than 10, the looks of this gets a bit messed up, because if you have, I don't know, 14th of November, then it's like 1411. It looks fine. But what if it's like 6th of June? It's like 6-6. So it won't be in the structure MM and DD. So I have one trick for taking care of that. There is a method for strings called zfill. I will write it, then I will continue explaining. So .str.zfill. Okay, so if you have a string, it can be anything. If you put zfill and then a number inside zfill, it will make sure that your string has that many characters. So in my case, if month June is only one character, which is the case. Month June is 6, so it's missing one character. It will make sure it will be two characters by adding zeros at the back, like at the beginning. So if I have 6 and then I use Z field 2, it will put 0 before it. It becomes 06. So it will make my MMDD, like I make sure it's fine. If it is 2 digits, like 20th of June, 20, it doesn't do anything. It's already 2 characters. If it is less than 10, then it adds a 0 behind it. So it works directly on a strings. So if you have a text like A, and then you put a.z field 2, it will become 0a. But in our case, this is not a string. Do you remember what is this now? What data type do we have here? This data months str. So when we are accessing one column of our data frame, what are we actually getting? It's one dimensional. What was it called? It's a series. So if you just access this without str, you're gonna get error because you're applying this Z field only works on strings. If you apply it on series, it doesn't work. But pandas has a trick. If you want to access the functionalities that come for strings, for example, if you just put the series .str then .z field, it will know that okay, this Z field is a string operation. Let's continue this and then I can explain more if it is still unclear. So now I have mm. Then in between I want to have a dash. So I just put it like this. Then I want to have dd. And I do a similar thing for dd. So I just use what I had in the day string. In data day str. And I'm going to do the same thing here to make sure it's 2 characters. I will use str.z field to make sure that it will be what I get as the output will be 2 characters. Yeah, okay, here it was underscore. Okay, so now we see it worked, and you see it worked nicely. Because of the Z field we added, it added a 0 behind. So if we hadn't done this, and you can try this now, it would give you 6-1. But because I use Z field, it is formatted a bit more nicely. And you can test. So now I give you 1 minute, try 2 things. Like redo this thing without the Z field, see what it will look like. And also redo this without adding this str to see what kind of error you will get. So just take 1 minute, try these things, and then get back to what we have now here. So we want to continue with the correct data. But just try that out so you get an understanding what I have done here. Okay, so did you manage to do that? What error did you get when you got to this? Yeah. So this Z is an attribute of a string. So in our case, we have just a pandas series. Even if the data type is string, still what you're getting is a series. So if you put that as str, then pandas will take care of that for you. So yeah, so that Z field is useful. But of course, this is how we are. What we do is depends on our data. So the data we have gotten from FMI is in this structure. Previously in this course we have had data sets, and you will have it in your exercise, something similar to this. So the data is coming in this format. So it's just a long integer with year, month, day, and hour. So you might get your data set from some source, and in that source, the date might be recorded like that. In FMI, it was just separate columns, very neatly separated everything. So depending on what you have in your data, you might use different approach. Yeah. Yeah, exactly. Yeah, yeah. Then you get the whole column as a series. Yeah, so depending on what you have, you might use different methods. So here we have put an example that if you come across some data set, for example, in your exercise or in your work later, and you have, for instance, the dates recorded like this, 2019, October 12th, 11:50 p.m. So if it is recorded like this, then you might need to do something like a slicing to break your string. Now it was different. We have separate columns. We put them together. Well, so you have to always check your data to see what you have. But in our case, we don't need to do this because our column was like this, and we just combined month and day, and we are happy with what we have as the output. Now we have the dates for each reading. We can use it to do the aggregation. But we will do the aggregation after the break. But before the break, let's still take a quick look at one optional part. So for our case, we have just month and day, and we are happy with that. It's enough. But imagine if you have a large data, and you have a lot of readings from many years and days and hours and everything. Then it gets a bit messy, or not messy, but I don't know, less intuitive to work with these strings and do what we just did. Python has a data uh, it has a data type. You have already seen like float and integer and those data types. In Python, we also have a data type called date time. So it recognizes that this is a date. It doesn't just treat it as an integer or a string. So far what we have done, Python has no clue what is MMDD. It's just string to Python. But with Python, you can just load. You can tell Python that this is a date. And then it gives you a number of functionalities. So with Panda data frame, so here is an example. If you have the date, we won't do this here right now. We don't need it, but we can just quickly take a look. So I can tell, I also created a string for year. So we already did this for month and day. So here I'm doing it for year. So I will also have year in the strings. Then I'm doing this whole thing again, but also adding the year. So let's just do that. So I just created a new column called data string that has the date, full date like this. So 2024 601 like this. So now that I have this full date, for that date time to work, it has to be a full date. It can also have time. Then you can easily convert that to a date time type. So I can just convert that column to date time type. So I just create a new column called date, and I convert what I had in this data string to date time. So if I now print this out, you can see it looks a bit different. It has dash. I didn't put that dash there. So it's Python's way of showing you that, okay, it recognizes that this is a date. It's 1st of June of 24. So then there are a number of good things you can do because it knows it's a date. You can do a number of things. So if you want to access the year, you don't have to do string manipulation. You can just say, okay, from this column, which is already a date, give me year. So data.dt.year. So here I'm doing the same trick as I did with zfield. I'm telling, because I'm getting a Python series, I'm telling pandas that this is actually a date time object. So don't give me an error. So it just gives you a year. So you don't need to manipulate the text. Same with month, same with day. If I want to get the number of unique months, 3. So we have June, July, August. So this is the number of unique values we have. So what we did already with months and day, you could achieve also using this. So you can use the months, day, date, the date object we created to create this column. But we are not going to use that. It will give you the same output as what we had. We already are happy with the MMDD we created, and we are going to take a break now. And after that, we are going to continue with our data aggregation. So let's take a 10-minute break and come back here in 33.